today's topic is going to be a very interesting topic, and it's all about in chaos engineering. I hope you guys learn something new today. So the topic is all about from chaos to calm, enhancing reliability and resilience. So I just probably stick with some of the best practices in chaos engineering, and this session is going to be a very helpful for the people who is in DevOps engineering, and rest of them I'm just going to dissect the concepts as well as the complexity in chaos engineering. So let's get started. So the agenda is all about the reliability in DevOps and chaos engineering and continuous resilience, maturity model, and the best practices. So we will be talking about the word chaos in every each slides and the chaos engineering topic as well as the resilience enhancing. So let's move on to the next topic. So have you guys know what is? Can somebody tell what is chaos means?
I can only say that when the project is fully in chaos, that is chaos engineering.
So, okay, chaos is something like a panic or confusion moment. Okay, something gets failed or something got something wrong. That is something causes chaos. Say, chaos is something often called as a butterfly effect, or else scientifically it is called as a chaos theory. Some because of condition happens in one side, it significantly makes differences in another side. So chaos is unpredictable. So chaos is everywhere. So that is what chaos it is. So the real world examples we can see in something. First one is strength testing on a bridge. So consider there is a bridge between two islands. So people used to travel in a daily basis. So how will you ensure the strength of a bridge? So when there is an excessive load on the bridge. So if there is an excessive load, what can happen if something goes wrong? Who will be taking those responsibilities if something goes wrong? So another example is cricket matches in OTTs. Consider your IPL match RCB versus CSK in fully hosted digital cloud. We guys usually know who's gonna win the match, but what happens when there is a network interruption or else server interruption for one region of customers? Almost 15 to 20,000 customers are lost their internet connection or something goes wrong. Who's gonna take those responsibilities? So there is a famous quote, everything fails all the time. So prepare for failures, nothing fails. So with that, we will move on to the next topic. So have you guys ever heard about the RRR, the three R's? So what is RRR? Why it's so important for smaller teams? How does it make any changes? What are the KPIs that is need to be considered? So let me answer with that. So RRR is nothing but your reliability, resilience, and robustness of your product. So it just enhances better efficiency as well as adaptability and risk mitigations of your products. It can effectively handle multiple application workloads and high traffic incomings too. So some of the KPIs that we follow is the mean time to recovery and the mean time to between failures. So I just don't want to confuse with that more. So let's move on to the reliability topic. So reliability in DevOps, the agenda first topic. So reliability is not a new topic. It's been there for ages. So we have 4 nines reliability, 5 nines reliability. So today is too much digitalization. People are doing businesses. We get frustrated when something doesn't work. So the customer expectations are at high today. So no, even people at no computer knowledge doing money transfers and they get fed up if something goes wrong, if something fails, they're gonna just blame the entire internet. So who provides that reliability? That's the big question today. So reliability in DevOps, let me talk reliability in more. So who should do that? There is a misconception that reliability need to be given by only the SREs. SREs is nothing but site reliability engineers. So they only manage the reliability of the system. Who gets fired if something goes wrong? Okay. So some of the positive trends that we are following in DevOps today. So first thing is reduced downtime. So today we have a CI/CD, that is your continuous integration and continuous deployment. So which makes the works way more faster and faster identification of issues and fixes in the pipeline itself. And the second thing is early reduction with automation and DevOps, which makes a magic to developers and enhancing automated rollbacks and continuous monitoring. And the third thing is infrastructure as a code. IAC provides a predictable and way and makes manual errors elimination as well as finding the resource outages. Shared ownership, that is your SRP, that is your shared resource principle, helps in finding out the troubleshooting in a greater way. And the developer focuses only on the testing in the CI/CDs, which ensures the system's reliability. And finally, security integration and minimizing the vulnerability of the product and improving the overall system's reliability. So this is all the some of the positive trends that we talk about in DevOps, but no one talks about the dark side and the challenges in DevOps. So challenges that we face today is speed is an ultimate challenge. Everybody wants to move into Kubernetes today. The sales pitch for Kubernetes is high today. So why I just need to wait for somewhat 5 to 6 months, just put hundreds of billions of dollar, increase the customer satisfaction, deliver the features in a next week. So the pitch for Kubernetes is accelerating. It's moving high. So my customer expectations are very high today. So for that, speed is a challenge. The faster delivery of the product, as well as the customer expectations and future are expecting before my competitor takes away my customers. So speed is a challenge, and if we focus on the speed while doing it a fast way, so quality is the main problem. So because we have to invest way more in automations and deal with numerous number of scenarios, and retaining the code quality is a main problem here. So why just waiting for a way? Move it in a container. You don't need to worry. So just write those processes in a nice and deliver it in a nice APIs and go home. But who take care of this? So it's a headache. So managing the quality is a issue in DevOps. And the final thing is productivity. Either is a developer's productivity or the team's productivity, whether they are spending more time on features or fixing the bugs and ensuring the code quality and retention of the entire product. So nobody talks about the reliability when you put a wrong configuration, maybe a developer problem or a design issue. Is reliability a goal? That's what I'm trying to push. That is where your continuous resilience comes in. I'll talk about that in later. So in reliability, the ultimate questions are the reliability of what, the reliability of against what, how to measure it. So people measure it in a way, 4 nines, 5 nines, 6 nines. Okay, I'm a developer. Oh, what are these numbers? I don't know. What are you talking about? Okay, so you just need a right angles to measure it. So outage is something seen by your end customers. Okay, when a fault happens or else server outages is happening, it's something that is seen by your end customers only. So reliability of what, reliability against what, how to measure it can be answered in reliability of business services, reliability of against various types of fault, and steady state checks. So reliability in business services in order to maintain customer satisfaction and trust and loyalty. How much trustworthy is my product, and security concerned, and instant customer support, as well as feedback improvements. So reliability of against what? So something software faults or human errors, something resource outages, or else anything natural disasters that happen to my resources. So how to measure it? So steady state validations or steady state monitoring. We have monitoring tools, logs, alerts, and metrics. Some of the third party tools we have. So with that we can measure it the steady states. So why reliability? So in the test for reliability. So the traffic surges and loads. So remember when you open IRCTC at 11 o'clock, 11 o'clock, the moment the Takkal opens, you can't query anything because there is a large traffic, So that is where your traffic surges and loads and multi-cloud deployments. We are using test, dev, and production in across various cloud providers and regions. And outages, something like your third-party outages, like your email service providers or your payment gateways providers. So when there is an outage, your customer get frustrated. And auto scaling and elasticity. So how does it perform well when there is an high throughput and latency, when there is an high customer incoming? So how my product scales within the server itself? So disaster recovery is nothing but how when there is an server fault, how does my system comes back to a normal stage? That is where disaster recovery comes. So we'll talk about this in little bit. And the test for reliability is first one is observability. So it's nothing but your console.log or else your print statement in your program. So there is some third-party tools also available for observability. And load testing is injecting your numerous number of loads to your application. So some of the tools like your Apache JMeter or Locust you can use to load the tests in your application. And fault injection, you can use fault injection, insert faults, and insert known faults and unknown faults into your application, whether how the application performs you can measure it. Security testing is nothing but your penetration testing. You can injecting some SQL injection commands or else something cross-site scripting commands in order to test the reliability of the product. And finally is chaos engineering. We will talk about that in next slide. So chaos engineering is nothing but a simple concept. I just need to explain. I think most of you went in roller coaster ride, right? So the moment when you sit in a roller coaster and you guys buckled up and think you are safe, and then it starts, it goes, zoops up, and finally comes back. And I'm think I'm safe and I'm back. So chaos engineering, I just need to say in a layman term, it's like a roller coaster ride for your application. You purposefully add faults to your application and measure it how it handles those situations indeed. So experiments that brings weaknesses to light. So you potentially add known and known faults and unknown faults to your application and measuring how it is performing in a situation. Yes. So experiments that bring weaknesses, so which enhances the confidences with my stakeholders. So resilience is nothing but a bounce back method. So whenever a server faults happen, so how my system bounce backs or rollbacks to my normal state. So it doesn't matter what I changed. Okay, I put hundreds of faults to my system and check how my system behaves in any faults. Any fault should be happen. It should be a reliable one. So introducing controlled faults to my application and checking how it is reliable as well as handling those vulnerabilities indeed. So that is what chaos engineering. So who is using chaos engineering today? So most probably most of the financial services and disaster recovery scenarios, scaled environments, e-commerce. So financial services includes all most of the banks like your JPs, Deutsche, DBS, Morgans are using chaos engineering today. So most probably some of the Asian banks are yet to follow these chaos engineering by 1 or 2 years. If I'm wrong, maybe some of the banks will be following chaos engineering today. So with that disaster recovery scenarios, so most of the NBFCs or RBI related stuffs, they'll be following those disaster recovery scenarios. They have to prove that they have done DR testing or else their license will be cancelled. So with chaos engineering, we can just automate those DR testing in whether in development or in pre-productions. So scaled environments, most probably fintechs, telecom industries, they have some high throughput. They have to handle their customers in unexpected issues. So e-commerce, whether you are Amazon or Flipkart, you just got big billion days. You can't say something got stuck in between. You have to tackle about millions of customer at one time. So in that chaos engineering helps to tackle high traffics and latencies, providing a 24x7 service. So chaos engineering, how to adapt to chaos engineering? That is where the adaptation pattern comes here. So first level is infrastructure level chaos. So you have to find out the network outages, your memory spikes, your virtual machine down times. You have to find those in infrastructure level chaos. And the second thing is resource level chaos, whether it's memory availability or RAM availability or else any performance bottlenecks that you have to find out in resource level. Third thing is your API level chaos, any third party APIs delays or any random exceptions that you got or some other cloud providers issues, any API throttlings or rate limiting that you have kept in there, or else any third party APIs authentication has been failed. So that is where your API level chaos comes in. And fourth one is your application chaos. That is a myth. So application chaos, maybe you have your database integration issues or else something, a configuration drift has been some done by a developer or someone. So finally is an operational level chaos, maybe an human error or else any communication disruptions has been happened in the operations. That is where your operational level chaos comes in. So these are the adaptation pattern for the chaos engineering. So with that, I move to the next part, that is your designing chaos engineering experiments. So I have some interesting metrics today. So we have a known and unknown. So with that, I start with the known and known issue. So known and known issues, that the things that you are aware of and understand. That is, you introduce some latency and then you know the results. Okay, you introduce some faults, you know the results. That is your known and known issue. So unknown and known issue. You don't know things you understand, but you know aware of what. So you don't know why my app goes down, but who will who the how the system respond based on it. The fault is unknown, so but what's gonna happen, what will impact will happen in the next scenarios. That is your unknown and known. And known and unknown is deployed to something things you are aware and you fully don't understand. That is, your application is moved to a Kubernetes or a container. There is a pod attached to it. I think you already know when there is a pod is killed, it already comes back. I mean, Kubernetes naturally comes back when there is a pod is deleted. So that is your known and unknown issue. So unknown and known, you don't know what happened. You are not fully prepared for it. So that is your unknown and unknown issue. So while designing chaos experiments or else fault testing, I'll probably stick to known and known issues only. That is where your level of vulnerabilities as well as your latency testings can be done with known and known testing. So if you are starting chaos engineering today, just probably stick with the known and known issue, and then primarily you can focus on all the rest of the parts. So today's chaos engineering has wide about, and the implementation challenges are there. So don't know where to start and what to test. That is what the first implementation, and how to score, how much we have covered the score. What is the maturity model we have to follow in that. So don't know who will manage those responsibilities, whether the developer has to take care of those responsibilities or the SREs or the QA teams who will take those manage and responsibilities. So how to measure it, how much we have covered the scenarios or else the chaoses. So what is the return on investments and the DRs that I can promise to my customer, which I have done in the chaos engineering test. So these are the some of the implementation challenges in chaos engineering. So with that, I move it to continuous resilience. Resilience, I already told you about. Resilience is nothing about a bounce back mechanism or a rollback mechanism. If something goes wrong in your application, it automatically needs to comes to a normal state. So in chaos engineering, continuous resilience should be tested in development as well as QA as well as in pre-production. So if you are hiding something in pre-production, means there is a millions of bugs inside in it. So that is where your continuous resilience testing comes in chaos engineering. So the resilience scores are finded about based on the average success of steady states that we have given in a given scenarios. That is where your resilience scores comes in. And the resilience coverage, that is the how much that I covered in my chaos engineering test. That is your number of tests divided by the total number of possible tests into 100. That is these are the resilience score as well as your resilience coverage for your chaos engineering test. So with that, I move to the maturity model. So maturity model is nothing but step-by-step evaluation, step-by-step adaptability for chaos engineering. So these are the 4 steps to get gel with chaos engineering. The first step is about start or test. If you haven't started chaos engineering, learn about it and create some small C experiments, test it on whether in development or QA or in pre-production. Develop simple scenarios and blueprints and win those stakeholders' confidence in a first level. And the once you are just done with the first level, and then move to the automation level, that is running way more simple chaos experiments and adding some faults, injecting some faults to it, cover all the basics and prove chaos is within the team. So once you're done with the QA team, you can prove that chaos is for all the teams also. So and third one is scaling your application, creating a simple game days. Game days is nothing but your chaos experiment days. You can find out a simple day and inject those chaos experiments into your application and test those vulnerabilities and reliability of the product. And once it is done, expand those chaos experiments across all your services. Once you're done with in second point, you're just adding some chaos only to some business services. In third level, you can add those chaoses to all your experiments and your services and expand to other teams. And once you are done with then you are expert level, create some game days and expand it to other teams based on your product's life cycle. So that is where your maturity model comes in play. So some of the best practices that for chaos engineering is for QAs, collaborate with the development team, start your chaos engineering testing with some basic scenarios and move on to higher level of unknown and known scenarios. So creating a realistic test scenarios, we know something gonna happen if something goes wrong, but there is somewhat more than a unknown issues are there in real time. So creating a realistic test scenarios is way more important. And third point is about documenting those experiments. So documentation is way more important. So So documenting those experiments is a greater way. So analyzing the scores and metrics, we have already seen the resilience score as well as the resilience coverage formulas. So scores and metrics will be in a greater way in order to measure how we covered the total chaos engineering test. And final thing is iterate and improve. So once you are done with some level of testing, and improve yourself by adding some end-to-end customer facing issues in chaos engineering experiments. So in summary, I just need to talk about the first point is resilience building is a continuous activity. So everything doesn't comes in a day. So it takes ages to build it. So resilience building is a continuous activity. You have to stick with it. Although the ultimate aim is to identify the weaknesses and the vulnerabilities in my application in our system before it impacts my end users and customers in a great way. So third point is starting the chaos engineering with few people in QA. So just apply the chaos engineering in one business service or one level of APIs or service, and then expand it to other business services. That is where your third point comes in. And fourth point is embrace failure as a natural occurrences. We humans used to make errors all the time, so it is always better to fail and fix. So start small and increase it gradually by making chaos experiments, and plan and execute and analyze those experiments in a greater way. That is where your summary comes in. So any questions? Thank you guys.